Okay, guys, we're going to start with this number one here. We are going to do a couple word problems. This is page 4 in your packet. What I want you to do is go ahead and work out number 1 here. It's very close to number 8. Number 8 in your packet. Or number 8, which is on page 2. Page 2. I'm going to ask you first, what is the sign of A? So keep in mind, I'm asking for the ratio for that. Okay, so whenever you do this, sign of A, this is your reference angle. So you're going to go across. This is opposite. This is the hypotenuse. This is the adjacent. And then you may have to use Pythagorean theorem to find x. If you do that, you would have x squared plus 5 squared equals 13 squared. You end up getting x equals 12 down here. Okay, so since A is our reference angle, 12 is the opposite, 13 is the hypotenuse. So if we use SOHCAHTOA, all right, we can figure out which one we use for sine, cosine, tangent. So sine is opposite over hypotenuse, so opposite over hypotenuse, that would be 12 over 13. Cosine is adjacent over hypotenuse, that would be 5 over 13. Tangent is opposite over adjacent, so that would be 12 over 5. So now we're switching perspectives. Now we're looking at B. So now this is opposite. So anytime this happens, the opposite and the adjacent just switch. Hypotenuse always stays the same. So now I'm switching those. Sine of B, of angle B in there, sine would be 5 over 13. Cosine would be 12 over 13, and tangent would be 5 over 12. Now, here's the difference. Anytime it says sine, it's like, okay, what's the ratio? What's the fraction? Anytime it needs the actual angle measure, if it says what is the measure of angle A, like it does here, you have to use the inverse operation. So you could choose any of these with A. I could do sine -1 of 12 over 13. I could do cosine -1 of 5 over 13. Any of those. It should give you the same answer. So if I go sine -1 of 12 over 13, I should get something like 67.4 degrees. Now if I need angle B, I can use any of these that have angle B in them. So maybe I do sine -1 of 5 over 13, which would give me something like 22.6. Which should make sense because these two need to add up to 90 degrees. All right, now we're going to go into some word problems. What I'm going to do is I'm going to help you set them up, and then I'm going to have you actually solve them too. So, a ladder is 20 feet long, leaning against the house, and reaches to the base of the window, 14 feet off the ground. What is the measure of the angle formed by the foot of the ladder? So, here's the deal. I would circle all of the numbers that we need. So a ladder is 20 feet long. The base of the window is 14 feet off the ground. What is the angle formed? So I'm looking for an angle. That's telling me I should have a theta somewhere. An angle formed. So I'm going to draw a figure. All right. I've got my ground. Got my house. All right. And I have a ladder here somewhere. Here's my wonderful little window. So this is the base of the window. Somewhere up here. Okay. And so I'm going to have different sections. All right. I'm going to see if you guys can get where it would be at. So I have a yellow spot here that represents the distance. I have a green spot here, a purple spot, and I have a blue spot. So that's the angle. Okay, I'm trying to figure out the best way to do this. And then I can have a pink spot right there. So purple, pink, blue, or light teal, light blue, yellow, and green. So now I need to figure out where all these numbers go. Okay, I'm not going to use not everything's going to have a number with it, but I have to be able to figure out which ones those are. Okay, so a ladder 20 feet long. So now I'm going to ask, where's the ladder? Would the ladder length, would that represent the yellow, the green, the purple, the pink, or the teal, or I'll call that teal. Okay, so ladder is here. This would be 20 feet long. Okay, it says the window is 14 feet off the ground. So then I need to put the 14. Is that which one of these colors would the 14 represent? Okay, window up off the ground, that would be 14 feet. Window, ground, 14. Ladder, 20 feet. What is the angle formed by the ladder and the ground? Ladder, ground. That would go right here. All right. Now we can go ahead and solve. So then I can circle my angle. This is opposite and the hypotenuse, which tells me opposite and hypotenuse, if you use your SOHCAHTOA, opposite and hypotenuse is sine. So I'm going to go sine of theta equals opposite over hypotenuse. So it would be 14 over 20. Then I have to do the sine -1 of 14 over 20, which would give me about 44.4 degrees. For either one of those. All right, I'm going to jump down to number 3 here. So then, ramp makes an angle of 9 degrees with the ground and reaches a door 3 feet from the ground. How long is the ramp? So I got this. I have a door that's like up off the ground here. And here's my door. Okay. And then it makes a 9-degree angle with it. So here's my ramp. So I'm going to do my colors again. So I've got green representing this length. I've got purple. Okay, so now I'm going to ask, where does that 9 degrees go? Does that 9 degrees go, what color does that go with? It's going to go right here with the ground, 9 degrees. Okay, what color does the 3 feet go to? Okay, that'll give me my height here off the ground, 3. Okay, how long is the ramp? So now I need to put an X somewhere. how long is the ramp. So then, this is, again, opposite and hypotenuse. So I do sine of 9 equals 3 over x. From here I can cross multiply. I get 3 equals x sine 9. Then I will divide by sine 9. Here you get x equals, if you do 3 divided by sine 9 in your calc, you get 19.2 feet. All right. So if I go for number 4, here's what I'm going to do. I'm going to have you guys set it up, and then I'm going to come back and see if we can fill the numbers in the right spot. Okay. Here's my telephone wire going here. So first question is, where would the 16 go? 16 would go here. Telephone pole, 16 feet. Where would the wire go? Angle 14 degrees with the pole. So wire, pole, 14 degrees would go right here. All right. And then how far from the bottom of the pole should it be placed? So where would x go, knowing that? X would go right here. Bottom of the pole, how far back from the bottom of the pole? From there, we should be able to solve. Okay, so go ahead and solve that. Here I have opposite and adjacent. So this is tangent of 14 equals x over 16. So when I cross multiply, I get x equals 16 times tangent 14, which turns out to be about 4 feet. Okay, so now let's do number 5. I already have it set up there for you, and all you have to do is find the angle for that. All right. And we've got 68.2 degrees. 15 is our opposite, 6 is our adjacent, so that means we use tangent. Okay, go ahead and read number 6 and then set up your picture, and then I'm going to do that myself and ask you where each number goes. All right, the first one is, where does the 25 feet go? Where does the 25 feet go below? Okay, so it's a point on the ground from the building. Here's the ground on, here's the building. So this is going to be 25 feet. All right, where it says the angle of elevation. So if you think elevate, angle of elevation to the top of the building, where would that go? So looking up, elevate, looking up, elevation, the 57, it's going to be down here. How tall is the building? So where would the x go? How tall is the building? X would go here. And then go ahead and set up your equation and solve. Okay, go ahead and draw, or you should get 38.5 here. You're multiplying 38.5 for number 6. Go ahead and set up and draw number 7 and see what we get. Okay, so here's my picture. I've got Billy. All right. The first number we want to place is the 5.5. So where do you guys think that would go? Okay, here's Billy, 5.5. That is going to go right by Billy. So think of, think we did a Statue of Liberty one when we were back at school. Okay, with the elevated triangle, this is one where we're going to start seeing triangles elevated off the ground. He's looking to the top of his Empire State Building at an angle of 80 degrees. So where would that one go? 80 degrees is here. If he is standing 257, where would 257 go? Here's the building. Here's him. 257 feet looking up. What is the height? What is the height? So where would X go? Boom. Okay. So keep in mind, whenever you're solving this and setting it up, keep in mind in the triangle is just from here to here. Okay. So whenever we solve for X, I might have to do something with this spot right here at the very end since it is elevated off the ground. So go ahead and do that and then type in your final answer. Okay, so we're going to be using tangent here because we have opposite and adjacent. So it would be X over 257. You should get 1,457.5, but don't forget about this 5.5 here at the end. Okay, since he's looking up and he's 5.5 tall, if I need the whole thing from here to here, I need to add the other 5.5. So your total answer should be 1,463 feet. There we go.